All right, there are a couple of people here still trying to join, but Daniel, we can get kicked off and I'll monitor the lobby. So, floor is yours, sir.
Okay, perfect. We'll go ahead and get started. Welcome everyone to another CPSS Prep webinar, and thank you all for joining us today. My name is Daniel Yu. I'm the sports scientist and strength coach for the Orlando Magic, and I'm here joined by my co-host Nick.
Welcome everyone. My name is Nick Seamy. I'm a physical therapist and athletic trainer with the Charlotte Hornets.
Perfect. And I'm going to introduce our guest speaker. Dr. Morgan Smith is a sports scientist and female athlete researcher. Previously, she was part of the Tsai Human Performance Alliance at Stanford, where she worked with the women's sport teams to investigate the molecular biomarkers of peak performance and fatigue. Really excited to have her join us here today. If there's any questions, feel free to put them in the chat, and Nick and I will help moderate. And then with that, I'll pass it over to Morgan. The mic is yours.
Awesome. Thanks, y'all. Excited to be here and talk you through kind of the work that I've been putting together over the past, I don't know, maybe 8 or so years. And before I kind of hop into application of biomarker monitoring in sport, I like to just give a background of who I am and how I see sport and quite honestly the world. And so one hat that I like to wear, a lens that I see through is as a scientist. And as Daniel mentioned, I was a postdoc at Stanford for 3 years where I did a ton of female athlete research and female athlete education, as well as a lot of community engagement. And a lot of my work centered around how do we bring science into sport in a way that makes sense, in a way that can be integrated and not burdensome. And so we're able to do a lot of really cool projects, one of which I'm going to talk about today. And actually, that middle picture is us collecting data like on a field with a team. So really, really fun to do that. And again, really kind of getting into this like the concept of how do we integrate science into sport, both from like a logistics standpoint, but also the people. And then my other lens that I come from is as a coach. I've coached high school track for years now. And I think it's a really important experience to have, an experience that I utilize because, of course, I'm an academic and scientist by trade. And it can be really easy to forget the human component of what we do and also the performance outcome of it. And as Daniel mentioned, I'm a part of the WUSA Human Performance Alliance. And, what we're really trying to get at is of course, science is cool. We all think science is cool, but can it be really useful? How can it be useful? And how can we apply it, especially when it gets a little bit more complex, like molecular biomarkers? So that's what I'm going to be talking about, but then also kind of framing of that coaching experience and working with athletes and being able to say, okay, if we're going to take a measurement, can I actually explain it to you? And are you going to care? And, how does this matter to your overall performance? So as we're gonna hop into it, I want to just define molecular predictors and then also performance. And this is a very short list. When we're thinking about what is a molecular predictor, it can be different proteins, metabolites, it can be hormones, inflammatory markers. It's kind of like the big one right now, of things that are also pretty easy to measure, but it's like anything on the molecular level in your body that might predict, I think is a really strong word because, and we'll get into it, part of my dissertation was I used the word predict and my committee fought me on it tooth and nail, which fair. But thinking about what are these molecular factors that we can collect that could be related to performance, and physiology. And so, how do you define performance? I mean, it's kind of you tell me how you define performance. I think it depends on what you're looking at. It could be the ability to train, to recover, to adapt. It could be specific metrics or a KPI. It could be availability or readiness, and you can debate about if are those the same thing or are they different. It could be a competition outcome. And so when you're kind of framing, asking a question of, again, going back to this molecular predictors of performance, well, what is performance and how are we defining it? And then how do you identify these factors that are going to connect to that? So like an example is, okay, if I'm looking at lactate, is that going to show me if the team is going to win? That's a hard stretch, And so I think it's when you're asking these questions about defining what performance is and what are the things that are impacting performance, we have to know, what that outcome is. Okay, so getting into the molecular piece, I promise I won't bore you with like too much physiology or molecular phys, but there's some really great papers I'm going to throw up here if you want to dive more into it. But this is from 2022, and it's literally called the Molecular Athlete, and it breaks down kind of all these factors that impact an athlete from both the nature and the nurture side, which is a whole conversation in and of itself. But you see different components around here that we're familiar with in sport, things like sleep, things like nutrition, ergogenic age, you've got gut health, and then you also have these other components like motivation and willpower. You have family, knowledge, coaches, you've got wearables, you've got recovery metrics. And so there's a ton of different figures out here that kind of detail what impacts an athlete as a whole. And then also, as you can see there with the little ribbon, with winning outcome as well. And then on this other component that I didn't touch on are epigenetic factors and genetics. My postdoc was in the genetics department, but I am not going to touch that today because I think, even I would talk to my advisor and be like, okay, we're very genetics heavy. I'm like, okay, if I'm going to talk to a basketball coach about this, we got to also reframe and think about what we're talking about there. So, but going into epigenetic factors of things that we can change our lifestyle. So what are the things that our athletes are doing? And then also like prior athletic experience, all that kind of stuff can impact those. But really just bringing this up of reminding us of all of the different factors that impact performance, which in a lot of our realms, like the nutrition, the sleep, the recovery, hydration, sunlight, those are all pretty self-explanatory, but also thinking about these other, the social factors, the emotional factors, the genetic factors all kind of play a role. And so this paper does a really nice job of breaking down all these different factors, and then it does extrapolate it out, as you can see in the title, from mechanisms to metals. So I think it's done really well. So I highly recommend checking this out. It's a long one. I will say that it's a long paper, but it does kind of bridge that gap all the way from molecular phys to winning. And I actually went back and dug up some slides for my dissertation, which was entitled, I believe, Molecular Predictors of Resistance Training Outcomes in Untrained Women. And so the concept of this was looking at the principle of overload. And you have people do the same program and they respond very differently. And so this is typically termed lower responder and higher responder. And actually, it's normally non-responder, which as a coach, I think is a really hard name. So I've rebranded that to be low responder because, you don't want to say someone's a non-responder to strength training. That just, they're responding in some way, maybe not the way that you're looking for. But anyways, not to get on that soapbox there, the ability for someone to respond is contingent upon a lot of things. And so this was a research presentation. So we talked about study design, but particularly training protocol. So we could all in this room do the same exact training protocol and have very different outcomes. And also the type of training protocol that we do can impact what we get, of course. And then also your outcome variables. What are you looking at? So even in strength and hypertrophy, so muscle size, what exactly are we looking at there and at what level? And then the methods part is a little bit more on the research side, but how are we quantifying this? In terms of response and adaptation to resistance training. And then another really great paper here that looked at just males and females in terms of responding to the same resistance training program, 16 weeks. And they had people that barely changed in hypertrophy and then people that had extreme. So again, kind of going back to this concept of you have the same program for a group of people and they respond differently. And so we're questioning, okay, what is it then? Because it could be an external factor, but we're trying to control for all of those things. So it's something internally that is having an impact here. And then again, just another paper, again, won't bore you, but you're looking at change in muscle size and change in strength. And so you have this like traditional bell curve of people being able to respond. And there were a few people that did a strength training protocol and like muscle hypertrophy or muscle size went down, which is an interesting setup there. But again, wanting to just highlight that there's something happening within muscle and within the body that is impacting someone's ability to adapt to resistance training, which right now I'm using as a proxy for performance. And this is my dissertation, and I will not get into it, but we did look at, okay, what are these molecular factors that may be the cause of that? And so we looked at satellite cells, and a bunch of other little things, but a lot of it, we didn't really see a difference in our small cohort. But we did see performance differences. So like we had women that had a small increase in their 1RM, like 10%, and then we had others that were like almost 200%. And so again, it was like before I even knew that I was on this path, I'm like, of this molecular predictor situation, of trying to figure out, well, how does the body respond to training is really the question that I was getting at, and what can we collect that's going to give us kind of more insight into that. And like I mentioned earlier, how do we take something incredibly complex and make it useful in high performance? And I think there's a growing interest here. And then the secondary question is, should we be able to collect a lot of different molecular variables, and do they really tie into high performance, which is a very loaded question. And really throwing this up here just to like visualize a lot of the different biomarkers that have been connected to a variety of things in performance. It's small and blurry, but it's just really showing that there's a long list of different things that you can look at. And again, another great paper if you want to get more into kind of like specific responses. But I mean, I think inflammatory markers that a lot of us are familiar with, or different like other markers like IGF-1 or different uh yeah, like different markers that you probably see up here that you're familiar with. And then I'll get into a project of what we looked at in the sport context. But you can get really deep into this, and that's something that I learned, especially when I was at Stanford, where we get molecular very fast and we're very scientific, which is great. And then how do we connect this to performance, which is what I was really interested in, can we win an NCAA championship? And what do we need to collect that's going to relate to that? And then this is just kind of breaking down, like if you were to look at biomarkers within a season, when does that make sense? And we were kind of chatting about off season and what that looks like and when would make the most sense to collect different measurements or to test. You can also think about this, and if you're going to do any type of performance testing, well, when do you do it? And when you collect it is going to be, contingent upon what they did before, right? So if they come off a 2 month off season, it's like, okay, we're gonna do performance testing the first day you get back. What is that? What is that profiling for us? And so the same thing happens on the biomarker level, because your whole lifestyle impacts what's going to show up here. And so this is like just a kind of detailing, when do you think about those things, which I think is a pretty important concept, especially in the sports science realm right now, because you can collect anything. You can collect anything and everything. And the question is now becoming, can we be more intentional about that? And when and why are we doing these things? Especially when we're talking about molecular biomarkers, I think the why, if you try to talk to a coach about, okay, now I want to talk to you about, different hormones in your blood and different proteins, they'll be like, I don't understand how that's getting a player to shoot a basketball. Like, how is that connecting? What I think is a very valid question. And so again, detailing timing of when you collect certain measurements is really important, which again, I think we're all really familiar with that. And so the questions that I typically ask myself when I'm thinking of any type of profiling or this molecular level is, well, what are we collecting? Why are we collecting it? And what's the reality? So are we even going to be able to collect those things? Are my insights going to be actionable, and are they wanted? And I am going to get on a small soapbox here about just the people component and the human component of human performance. And I'm taking this from a science level, not even a sports science, but if you're trying to be incorporating some research or some questions, are there buy-in from all of your stakeholders, which are your players, which are your coaches, your GMs, your ADs, like all of those people do need to be involved, of course, at varying levels, but that human component of not just relationships, but interactions and communication is really important, especially when you are getting to something that can be more sensitive, like what's happening in people's blood and bodies. And you say, hey, you have really high inflammation right now, and you're going into a championship run. how is that person going to interpret what you're telling them? And so again, connecting back to, is that information wanted? And if it's not, it doesn't mean that it's not possible. It just means maybe we need to have some more conversations, build some more rapport to kind of get there. And so that's kind of building into the project that I did with Tsai Human Performance Alliance and Stanford, looking at recovery profiling. And we investigated perceptual, physiological, and molecular markers of fatigue. And our question that we were trying to get at is, what does peak performance look like and how do we get there? Not just from a winning standpoint, but from a molecular standpoint. So I was able to work with the Stanford women's rowing team, which were NCAA champions the year that we worked with them. And so the question is, okay, if we're collecting different molecular markers, how does that actually connect to teams winning championships? And that's something that we hoped to look at. And I'm just going to go over a brief overview of the study just to kind of provide context here. So going back to timing, we looked at our preseason, in-season, and postseason, so we can kind of see how are these time points or predictors changing over time. And you're probably thinking 3 time points, that's not enough. That's was kind of the intention of when you're starting to work with a team and you're going to collect different metrics. You can't come in and be like, hey, we're going to do this every single week when they've been doing nothing. That's a pretty big jump. And in terms of adherence and all that kind of stuff is going to be hard. So coming in, working with the coaching staff and the players to make a plan of, hey, we're really interested to look at these like key points in the season. So this is your preseason, in season, and postseason. Again, this is on the collegiate level. Our training bout was chosen by the staff. So this is kind of going back into that collaboration piece of, I'm not a rower, and so I'm not going to say, hey, I need you guys to do this type of bout. The staff chose it. It's a 2x5K. If you've never done one, I recommend you trying it. You try it. It's brutal. And then our different outcomes. So this perceptual component of essentially asking players how fatigued they are and how recovered they are. We also did some CMJs to kind of get that neuromuscular component with their strength staff. And then on the molecular part, it's called microsampling. We essentially pricked their arm and got this very small dried blood spot. And we're trying to look at just different proteins, which ones are being upregulated and which ones aren't. We also looked at lactates. We did a finger prick and then C-reactive protein, which is from a finger prick as well. And then we took a saliva sample to look at 2 other molecular markers, kind of inflammatory markers. The key here is that we needed to get these metrics at baseline, and then immediately after they did their training bout, and then 24 hours later, we ended up having 23, but like in our first collection, we had almost 40 athletes, and we needed to get all of this done in 7 minutes. And so when we were thinking about, okay, we're trying to collect a molecular outcome, they're not easy to do. You typically need some type of biological sample, and we're not asking athletes to give a blood draw. We can't do that post-exercise. We are literally in a gym. So how are we going to do that? So we're like, okay, can we get a finger prick? What can we get from a finger prick that's as valid as possible and also is easy to do and that is not as painful for athletes? And then saliva. We're like, okay, like saliva should be pretty easy. And then again, you're taking into account how many people you're trying to go through. And of course, that team is pretty big. So depending on the types of teams that you work with, say you have 14 guys or 20 ladies on a team, it might be a little bit more feasible, but still, say you're doing one of the hardest workouts of your block, and then someone's like, hey, and then can you spit in this really quick? You got to think about that, you know? So those are the things that we collected there. Then we also gave them a wearable, but I'm not going to get into that part. Again, going into these time points that the preseason, in-season, and postseason, when we did these collections, this is kind of a snapshot of what we gave back to the athletes when we're looking at lactate. Okay, it's a byproduct of metabolism, but what does that mean? What are normal levels? The C-reactive protein, and we looked at another enzyme here. But an aspect of this too that was really important is, can we get the readings immediately? So if you were to get to your blood draw, and it might take a few hours maybe on the quick side, but sometimes it takes a long time to get data back. And when you're working with athletes, particularly collegiate athletes, they want to know. Like, they want to know what you're testing and what that is. And I mean, we have a really special experience because a lot of our rowers they're row for their national team, or some of them are Olympians, and so they know what lactate is. They're like, yeah, I get tested in my national environment, so I know exactly what it's looking for. And so having this information given back to them as soon as possible is really important. So this is just kind of like a snapshot of what that looked like in terms of results here. And I'm not going to get into the data because we're publishing the paper soon. But the question is, and this is kind of a hypothetical situation, say you're entering the postseason and your resting lactate is up and your resting CRP is down, which are not trending in the same direction. So these are both kind of inflammatory, like recovery markers. And so it's like, hey, we're going to go into NCAAs and we're getting this conflicting information. Like, what do we do with that information? How do you tell a coach? How do you paint that picture? Is the first half. Second half is then how is the molecular physiological side tying into how the athletes actually feel, which is, I'm not talking about wearables, but that's part of it, right? Like you look at your sleep score and it's 72 and players don't even ask themselves, like, did I think I slept well? Or then they start interpreting how they feel based off of numbers. And so it's really important to get this subjective experience and having athletes check in with themselves to see how they're feeling. And for us, we wanted to see if they trended in the same way, like molecularly and subjectively, or do they agree or do they not agree? So there's a perceived recovery scale where I threw the paper up there, but it's essentially you're asking 0 to 10, how recovered do they feel? And then the flip side of that is rating of fatigue. 0 to 10, what level of fatigue is the player experiencing? So we would literally just have these printed out on paper and we'd say, like, we'd show it to them and they can circle it. Super easy collection. I think these are, and they're also, reliable and valid. So I recommend these. But again, we're trying to pair the subjective experience of fatigue and recovery with a little bit of physiology and then also the performance on the test. And that was our way of trying to figure out how do we put these things together. And then the question was, how do you describe your fatigue? And to just kind of throw these up here, when we're looking at the molecular levels, and then again, this is hypothetical data, but their perceived recovery is up and down, and then their fatigue is up. When you're having kind of framing, collecting these variables, that's something we had to consider. What if they're going to go into NCAAs and all their markers are off? Inflammation is high, fatigue is high. How do you go to the coach and have that conversation? And then also at that point of the season, it makes sense, right? Their season's really long. When you get to the end of it, it's the battle of who can make it and who has, the highest level of performance. And it was fascinating to be able to look at these like these molecular, like things that we know change with exercise and change with fatigue and recovery. And you pair that with you're going into postseason. Well, how much does that really matter? Because the team ended up winning the NCAA championship. So if we're going back and we're looking at our variables of, oh, inflammation's high, like these molecular markers are kind of trending in a way that are not advantageous to what we think as a scientist as high performance. Well, sometimes that clashes with what performance actually shows because the molecular part is only part of it, right? It doesn't have the motivation, it doesn't have the discipline, it doesn't have the grit or the drive or the want to be a champion. And so I find that really fascinating. And, I'm kind of always advocating for having a little bit of objective markers to add to what kind of players are reporting and what the performance on the court, on the field, in the water is, because, for a lot of people, that's what matters. It matters their performance because they have money on the line, their jobs on the line, their spots on the line. And so it's a really interesting and complex conversation when you're talking about molecular predictors, because again, predictor is a really interesting word that I think you have to be very cognizant of, because we're not predicting their performance. We might be predicting a level of fatigue, but elite athletes can perform in high levels of fatigue. That's kind of the aspect that makes them elite. And so again, it begs the question of, yes, we can collect things, and just because it doesn't look the way that we anticipate it to look, that doesn't mean that performance is going to be impacted. Like we could have, and we probably all have kind of been in this experience where athletes come in extremely well rested and then they play and you're like, what just happened? Like, what do you mean? You've been off, you've been resting. Like you're eating well and then all of a sudden, performance is not there. And so the same thing goes on the molecular level. Especially when you're working with college athletes, like they don't sleep a lot. They're really stressed. Like there's all these things that are happening and they're still able to perform and they're still able to kind of be at their best, even though it's again trending in the way that we don't want them to or that we don't expect. And that's just kind of my recommendation of when you're collecting anything is where does it fall in terms of priority and in terms of impact for whatever the outcome is that you're measuring. Because it could be winning, but it also could be, I mean, for me, it was for the love of the game. I want athletes to leave their experience also loving what they play, which is not always the case. So there's no molecular predictor for that. Um, and with that, I want to say thank you of giving me the time and the space to talk about this. Would love to answer any questions, and we can get more into the nitty-gritty, but I want to keep it pretty high level and just also conceptually of how do you integrate this into your space and into sport. So thank you.
Morgan, thank you so much for that. I appreciated the endpoint on how everything tied together, and especially the point of markers might fall, but performance might maintain or even exceed your expectation. And then you're sitting back, you're like, oh, maybe we didn't intervene on that, or maybe good thing we, didn't kind of stick our neck out there trying to make a change, because it ended up not necessarily impacting performance in the end. The one thing I am curious to get your thoughts on is the thought of individualizing norms, especially for biomarkers. Like you have your normalized ranges for the three that you're looking at, like lactate, C-reactive protein, and the LDH. Do you find like if you're tracking athletes throughout the calendar year that they'll have like their own individualized norms and you guys kind of bump that to accommodate, or would you rather look at group norms?
In the science realm, it's more group because you're trying to get as much power as possible. So, you can always publish a case study or a small group, and reviewers and colleagues will always say, well, you don't have enough people to make that claim. And it's like, well, yeah, but the team only has so many people, like, and so it's from that science perspective, you can do both, but people tend to kind of go on the group level. That next piece would be to individualize it. And so like I've seen athletes and tested athletes where they like their resting lactate is just higher than normal, but it's like that every single time. And so you do have to create what those norms are. Another example is when you get I don't know if you all do daily wellness, but like we have players that are like always a three. Like it doesn't matter what happened before then. It's like, oh, this is just my normal. Or like they're always a five. And it's like you check in with them, they're like, oh no, I'm great. I'm like, okay, like that's interesting. And that's of course like more subjective. But yeah, like everyone's body is different. Everyone responds to exercise very differently. And so I think it is really important to get those like baselines. And if we were to do it again with a team that would love to be pricked all the time, I would do it like once a month, maybe once every 2 weeks to just start to get like create that baseline before you can kind of make really like more strong assessments of what's happening. But that's also kind of like the hard part of sport is like I'm like, hey, you're gonna get 7 minutes. That's it. Like do as much as you can. And so it's try to figure out what is the lowest hanging fruit that's also as valid and reliable as possible. But yeah, it's really important to take that into consideration, especially for individualized strategies, is I think where the money is. And that's where, I mean, for pro sport or elite sport, that's what it is, right? Every player has their own thing. They have the things that they like and like where, yeah, like how they show up every day is, can be consistent. So yeah, I think it's really important to do that.
And then one more question I can open up to others here, and it kind of tied into the last point that you made, but I'm curious, with your approach in academia or, on the research side, and you have a research question and you want to implement that like into a study and you have, athletes or a group, and that relationships are like mutually understood, like with where you're at and what your role and your goal is, like when you're there around the athlete compared to in the applied setting where that arrangement isn't there. Like you're not coming from, you have a background in academia, but that's not the arrangement like in your role. So how do you go about pitching that to stakeholders yourself? Like, hey, these are the things that I've done recently, and this is how I'm now doing in the applied side. Like, is that different in how you're trying to create buy-in for the work that you're doing now?
Yeah, I mean, as I mentioned, like I'm all about the human perspective, like the human component of building rapport and building relationships. And when you're coming into an environment where you are the outsider, I think that's really important to acknowledge. And especially if there's a difference in disciplines or backgrounds. So if you're coming from more of a researcher, even like a sports science base and you're talking to a coach, or you have to figure out what they want, what are they interested in, what are the things that they believe are going to move the needle. I think it's really important to lack an agenda when you go into those conversations, because I'm not like, I'm not the king of this house. I'm not the CEO of this. And so I'm always kind of framing that I'm a support. I'm an addition. That's not more time. It's not more work, but how can I either improve a system or provide information that will be really helpful to you? And so whether it's a coach or it could be an AD or a GM, it's like, hey, yes, this is my background experience. And also, what do you want? What do you need? Where is a gap that you have that we could potentially fill? And then I have an idea of what that, what those steps are, because I've done a needs analysis and research. So I kind of have a general idea. So I'm prepared to respond, but I'm not coming in with like, and I've seen this, quite a bit of research is like, oh, like this is exactly what I'm going to research, and I just need to find a team. It's like that's slightly backwards. Like you would have, if you have a team of interest, sure, and then you go and say, hey, how can we support what you're doing in a way that makes sense to you? And maybe there's some education component there, but you also have to recognize that some coaches don't want it. Like they don't want the education or the new stuff, and that's okay. Like you're not going to win everyone. And so I think it's like having that perspective of I'm here to support and I'm here to add on things that are going to be helpful to whoever you're talking about. And that looks very different depending on the level of stakeholder. Like if you're talking to an athlete, it's connected to you also figure out what they care about. So you might think, oh, it's definitely their performance. It could be, or it could be their quality of life, or it could be their fatigue or something like that. And so it's really getting to know people and then seeing, okay, now how can we evolve this to include something that can be really helpful? And sometimes a lot of it is like, it's you patience. It's like maybe they don't actually want anything additional. They just want a thought partner or a soundboard or something. And it will kind of build into being able to provide something additional. So it's not always coming in with the agenda of, I don't know what it is I'm going to provide, but it's something. It's like just being there to listen, lots of active listening and finding middle ground while also knowing that who is the gatekeeper of that environment and recognizing and respecting that.
Yeah, that's a great approach. And yeah, I definitely appreciate that because if you come into it from the perspective of, hey, this is what we did before, and then you try to impose that on the current situation, you know,
Yeah,
current stakeholders might be like, yeah, well, that's not here. So meeting
exactly.
them where they're at and having a slow burn and understanding the environment and where the needs are and having that intertwined with what the needs are of the organization and the group and the players will look different, but also important to be considered. So I think that's awesome. I think Daniel had a few, and then we can open it up to the group. But thanks for those.
Yeah.
Yeah, Morgan, thank you so much. This was such a good presentation. I feel like you broke down so many studies and just made them really simple, which is like not easy to do, especially for me. I know when I'm reading studies, like, oh, whatever, 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 and I'm just getting lost. So yeah, that was awesome. Um, I have a question actually following up on Nick's question of the norms initially. I feel like a question that I'm running into a lot in sports science is like, how many points do we actually need, data points or measurement points in order to identify change? And I know there's like meaningful change formulas or like standard deviations. Is there something in like the genetics or biomarker world where you guys are able to flag for change, whether off of baseline or just over time?
Yeah, that's a really good question. I think um what what I've typically like what I my go-to first look is change over time. So not necessarily like the raw values of where they started, where they ended, but how big is that difference? So it could be a standard deviation or could be a delta, just like what is the difference there? And that can just be between 2 points, right? Like if you're doing like max testing, they start somewhere, they end somewhere. Like two is enough. I think when, especially in the genetic side and big data, and like you can collect so many things, like, okay, I'm gonna, like a wearable, it's like, I'm gonna pull your wearable data for the past 3 years. And that can be really helpful. And there's a lot of great modeling there. I think in sport, we've got to be, it misses the context. So when you have your in season, your out of season, your preseason, if you lump all those together, it erases the nuance that you're looking for. And so it's really important to, if you have more data points, it's almost tagging them of, well, when did they happen? And like, what are important contextual factors that might influence what we're seeing and then bucketing that way. Like I said, I think any data is good data. The more the better with an asterisk. I think it's like more is not always better. But if you got a couple of months or a couple of weeks, that can be really helpful. And also it depends on the metric that you're looking at. So like on the female athlete space, if we're trying to look at something with menstrual cycle, well, 2 weeks is not necessarily going to be enough because we haven't hit everything that we need to see. And if you're, like I said, if you're measuring strength or you're measuring like, or if you're looking at something that's just like pre-post exercise, you only need one day. You only need to see like what that impact is. So there's not really an answer of a minimum. I think maybe some of my advisors and colleagues are probably like, you should give a stronger minimum. But to me, it's kind of, if you got two, and depending on what you're looking at, that can be helpful. And then, yeah, once you get a little bit more of like a history, I think that can be, yeah, I think that can be helpful as well. But it's not necessarily required. I think the other part of it is how the strength of the recommendation that you're trying to make. It's like, oh, we only have a week of data. So now we know exactly how they respond to this type of training. It's like, you don't like, it's only a week, so you got to give it some more time. So that's a very it depends answer, but I think you can make a lot of things work, even if it's not a lot, if your question and if your outcome is appropriate for it.
Yeah, for sure. That makes a ton of sense. And I actually like the it depends answer a lot because yeah, it does depend on like the type of question you're asking, I guess, for the number of data points you need. And then just one final follow-up question. For your paper, where you're talking about lower responder and higher responders. And I think the takeaway was that like people with less satellite cell response were the lower responders or had less of a response. Is there a way to increase that satellite cell response so that they would respond better? Like a solution. So like let's say like we
Yeah.
did it with our team, half of them are low responders or whatever. Like what
hmm
can we do to help fix that?
Yeah. So, no, we actually dug in a little bit into it. Yeah. So it was the if you started baseline with lower satellite cells, then you were more likely to be a lower responder. That doesn't mean that they didn't increase like their myonuclei. Essentially, satellite cells turn into myonuclei, and so the more that you train, they convert. And so that doesn't mean that they didn't increase that number. It was more so the only thing we saw significant was how many you started with, which is a very, very weak proxy for like how many you're born with, essentially, because we looked at untrained people, but they're in college, so I mean, they're not necessarily untrained. I'm sure they've done something to, especially like if they've done like youth sport or something or some type of like athletic development when they're younger, that's going to have an impact. But yeah, it was how many they started with, not how many they ended with. And this is from like a very small like cross section of muscle, so there's a lot of debate there of you have this little tiny piece of muscle and you're extrapolating it out to like the full quad. I'm like, yeah, I know. But you can't measure somebody's full quad. That's impossible. So yeah, I found that really interesting, but it also, I mean, I think it makes sense. Like I said, a lot of these, we say untrained, but it's like someone in our cohort like ran track in high school. I'm like, okay, well, that's going to have an impact on what your muscle looks like, even as a college student that hasn't ran in 3 years. Um, and so I think it's more of a reflection of really training, like your training history and your background. And so um, I think the applicable side of that, I mean, yeah, not only is training, especially when you're working with adults, I mean, they're like kind of developmental phase is over. So like, which is okay. But when you're working with youth athletes, what they do in puberty and in development is really important and how it sets them up in terms of muscle and physiology kind of later in life. There's a really cool paper that I didn't present that just looked at like muscle health and I think bone as well for, kids that started strength training when they were 7 or 8 years old. And then they kind of extrapolated out to they didn't start until they're 16 and what that looks like. And the people that started strength training younger ended up holding on to more muscle and all of that, which is more so from like the aging perspective. But if you think about it on the sport perspective, that's also like can be some not even assumptions there. So it's really just getting at training hard, making sure training is hard, because that's going to impact molecularly what it looks like, which can then like force output power. It's a small component of it, but it's still a component. And so like that can be trained. But yeah, for my dissertation, it's you're working with college students, they're a mixed bag. Like you don't really know what you're going to get. So that was my assumption of kind of what we looked at there. The people that had less satellite cells were probably more truly untrained. And then the people that started with more likely were athletes previously or had a lot of activity, which is again still an insightful conclusion. But yeah, those are my thoughts on that.
I
Awesome.
just
Cool. Thank you.
I just made the note of 7 years old. So our son is 2. So I made the note. So he's got a couple more years and then we'll start the training regimen.
Yeah, I mean, like stardom strength training. I mean,
Yeah.
it's people are like I working at a high school, they're like, "Oh, well, like young kids like can't move weight." I'm like, that's not we're not saying put 300 pounds on their back. That's saying like you can do movement competency. There's also a ton like really great literature about like kids that are confident in how they move are more likely to stay in sport and to be active, which is really important in terms of health. Of course, if you're working with athletes, they're already kind of active, but like teaching kids how to squat and lunge, and it can be games and fun and whatnot, but yeah, like there's, I mean, that's a not to put on my strength coach hat, but like the amount of girls in high school that don't lift because their strength coach doesn't want them to lift. And it's like, what are we doing? Like they can, like, oh, they're not ready to. I'm like, they're not ready because they've never done it before because you won't train them. Like that's why. But yeah, start them young, even like I said, it's not putting a barbell that's twice their weight on their back, but yeah, strength training's huge. The younger, I don't say the younger the better, but they can start young.
Noted. I'll make sure to tell my wife that too. Any questions for the group here?
I don't have any questions, but thank you so much for the presentation, Morgan. It was very insightful to see your experiences working, applying like physiological, a lot of physiological research in practice. I think that's really cool. And I look forward to seeing you here on campus in November, hopefully then. And it was a great presentation. Thank you.
Yeah, thank you.
Well, if there's no further questions, again, Morgan, thank you so much for your time. Thank you all for attending here this evening. We look forward to many more webinars in the future. So if you're interested in those and following along, you can follow us on Instagram at CPSS Prep. Same thing with Facebook and also YouTube. But again, Morgan, thank you so much. Daniel, thank you again. And until next time, appreciate your time.
Yeah,
Thank
thanks,
you,
Sean.
Morgan.